Going on now to topic 3 of chapter 1. Again, this is a light review of algebra and some of the basic things you're going to run into as you move along in Math 1108. We're going to review quickly the topic of factoring. Now they're asking us to factor this trinomial. It's made up of 3 terms. It's to the second degree. And in a sense, this is a product of something that probably, when they ask you to factor it like this, was made from 2 sets of binomials. So I'm not sure what technique you may have used before. And I do have a number of videos on the UNH_math_zone where I go over factoring in great detail, or as we cover it in Math 1103 in Chapter 5, great detail if you need some more on this. But anyway, we're going to, in a sense, undo the FOIL. And you recall when we did the FOIL, we multiplied this term by this term to get this. So that's easy to undo that. That's just going to be an x and an x. Now what we're going to do is sort of undo this. What are the factors of 18 that made this and this? But then when we did our outers and inners, add up to 9. So mentally we start going through the factors of 18. 1 times 18, no, that's not going to work. 2 times 9, no, that's not going to work. 3 times 6, that looks promising. Because if we add a 3 and a 6 together, we get the 9. So we put our 3 there and a 6 there. And these could be reversed, no problem. And then we look for the signs. These are all plus, so these are all going to be plus. And then we check it by foiling it, and it does check. Now here they're going to give you quite a detailed recipe, but it's similar to what I've just done as well. Okay, now for differences of squares, as you look at what we have here, x plus y, x minus y, you may have had a plus b and a minus b. That's a model they often use. So here are the same terms. One is a positive, one is a negative. Now these have a special name. They're called conjugates. And a special thing about conjugates, when you FOIL them, watch what happens. We get a squared minus ab for our outers. Our inners gives us a plus ab, and our last gives you a negative b squared. Well, when you multiply conjugates, the middle terms cancel out through subtraction in a sense. These are additive inverses of each other. So they cancel out. So you end up with a squared minus b squared. So this is called the difference of perfect squares. Whenever you see and they ask you to factor the difference of perfect squares, that will factor into their conjugates, which is what we have here. And as you do your practice and later the quiz me and your test, if you know this skill, that should be easy for you. All right, another famous one that they're reviewing here is this one. If we have A plus B, had a little trouble with my pen there, but if you have A plus B, the quantity squared, this is squaring a binomial made up of two terms. Now here is the sum of these terms. Here is the difference of these terms, and you are squaring them. Now there's a little procedure for that, a little recipe. We square the first term. That gives us A squared. We then multiply these two terms together, which gives us a positive AB. Then we double it, so we get a positive 2AB. And then we square this term, and we get B squared. And if we do the same to this, square the first term, that gives us an A squared. Multiply these two terms together, then double it. So it's a negative AB, so a negative 2AB. Square the last term, negative B times negative B gives you a positive B squared. Now, these out here are called perfect square trinomials. Perfect square trinomials that when you factor them will factor into their binomial squares. Perfect square trinomial factors into their binomial squared. Again, a useful technique, and you'll be working that. Now, another famous one, and I'll write that one out for you as well, are in this case the difference of perfect cubes. This is the sum of perfect cubes, and there is a recipe for factoring those. And here it is step by step. You make a parenthesis for two terms and a parenthesis for three terms. And it's pretty much the same for both. Parenthesis for two terms, parenthesis for three terms. Then you take the cube root of a to the third, which is going to be a. Use this sign here. And the cube root of b to the third, which is b. And the same here. So this is going to be a. The difference is that this is a plus, and then this is a b. So you take the cube root of that, goes there, cube root of that there, and this sign goes right there. Now, the very important next part is determine what is your middle sign in this trinomial over here. And if your sign here is negative, then the middle sign will be plus. If your sign here is plus, then the middle sign over here will be negative. And now you square this term, that goes right there. And it's the same for both. Now you multiply these two together, disregarding the sign, because this is going to be a positive AB. But you just multiply these together. Multiply these together, AB. And then you square the last term. Now, this is the factoring of the difference of perfect cubes, the sum of perfect cubes, and that's a recipe. And again, in other videos, I go over this in greater detail with lots of examples, but that's the recipe. And that's basically what they want you to cover in section 1.3. They'll want you to review those and actually deal with examples of factoring. Okay, here we're going to talk about rational expressions, and a synonym for this often is fractions. So just some pointers on dealing with fractions. Now, here they're giving you for this particular fraction, notice it's P times S and Q times S. And they're saying that neither of these are zeros. That would be undefined. So what do? Well, we see we have a common factor here. We can cancel out this common factor of S. That becomes a 1, and we get P over Q. This is simplifying fractions that have common factors in them. And the basic rule for multiplication is we multiply the numerators, multiply the denominators, and if you can't cancel anything out, that's going to be your answer. Now in division, when we do division of fractions, the rule is we change the division sign to multiplication and take the reciprocal of our second term. That is, we just flip it over and cancel out if we can, and if not, we just multiply the numerators, multiply the denominators. Remember, if you can't cancel out here, then in your final answer you can't cancel anything out. But if you forget to cancel it out, simplify, in your final answer, if you don't, they're going to consider that incorrect because you didn't reduce to lowest terms. Okay, so let's do an example here. That's good. Finally, we're getting some work to do. So we'll rewrite it. 8 over x times 5. I'm going to change this division sign to multiplication and then flip this second term. Now, what can we do here? Well, we can cancel out the 5, and that goes into there 4 times. Can't do any canceling here with the 8 and the 11, but we can cancel out one of the x's, and we're just left with a 1 here instead of a 2. So notice there's no more canceling, so we're going to go 8 times 4 is 32 over 1 times 11x gives you that. Now notice, if you couldn't cancel out any more over here, this is at its simplest form. Okay? They do cancel, they're not showing you that, but I did. Now here, we're going to add fractions. In order to add fractions, if they have the same denominator, we just add our numerators. If we're going to subtract fractions with the same denominator, we just subtract the numerators, which is what is illustrated there. All right, so that one was pretty easy, but often you don't have the same denominators, so I don't know if they're going to have you do this. Let me go back and give you one example anyway of what if they were not the same denominator. And I'll make it easy so you can see the process. So we have, let's say, 3/5 plus 2/3. Now, those are not like denominators. So in order to be able to do this addition, we have to have a common denominator in which we're dividing these pieces up so they're equal. So what would be the common denominator between a 5 and a 3? Oh, most of you know it because I picked an easy one, 15. Now the rule is we can multiply anything by 1 and not change its value. But I'm going to pick out a 1. Remember, there's a lot of different forms of 1. We have 1, we have 2/2, that's 1. We have 3/3, that's 1. We have 4/4, 5/5. These are all forms of 1. Now, what will I multiply this 5 by to make it a 15? Well, I'm going to multiply it by a 3. So I'm going to use the form of the 1 that is 3/3. So now I get an equivalent fraction here. 9/15 is equivalent to 3/5. And here I'm going to use the 1 in the form of 5/5. So 3 times 5 gives me my 15, and that'll be a 10. So this then becomes 19/15. By the way, this is a fraction. It's also sometimes called a ratio. Sometimes it's called a quotient. That's what this is. And for subtraction, the very same. Let's do a subtraction. So let's say 3/7 minus 1/3. I could make it any number, but I'm making it easy so you see the process. Common denominator is going to be 21. So I'm going to multiply these by a 1 in the form of 3/3, and this one by a 1 in the form of 7/7. Again, we want to get our common denominator here. So this will be 9 minus 7. So now that we have common denominators, we just subtract our numerators and we get 2/21. Notice this is an improper fraction because the numerator is larger than the denominator. And I can convert that by dividing 15 into there goes once, and there's 4/15 left. So this is called a mixed number. To convert a mixed number to a fraction, 15 times 1, then add 4, and that's it. Okay, you're going to be doing some examples. Hopefully this is helpful. Remember, bring any questions that you have to your instructors in Math Zone. I'm sure they'd be happy to help you with them. And now on to section, well, I'll tell you what, we'll keep this at 20 minutes. So we'll close this one out.